Good day everyone and welcome back to my channel. So today I'll be showing you guys the derivative of a product. So let's say we have a function y equal to uv, right? Let's differentiate this using the first principle differentiation. So we have that our y will be equal to y plus delta y on our left hand side, and then on our right hand side becomes u plus delta u multiplied by v plus delta v. And let's open this bracket on the right hand side. So we have that u multiplied by v, uv, and then u multiplied by delta v becomes u delta v, and then this multiplied this becomes v delta u, and then delta u multiplied by delta v becomes delta u delta v. Now let's subtract y from both sides of the equation. So we have that y plus delta y minus y be equal to uv plus u delta v plus v delta u plus delta u delta v minus uv, which is y, right? So some things will cancel out here. So this will cancel out this one, and so for our left hand side this will also cancel out this. So we have on our left hand side delta y, and then on our right hand side we have u delta v plus v delta u plus delta u delta v. Now let's divide both sides of the equation by delta x. So we have delta y over delta x, which is equal to u delta v over delta x plus v delta u over delta x plus delta u delta v over delta x, right? Now as delta x approaches 0, delta u as well approaches 0, and then delta v as well approaches 0, right? So let's take the limit of both sides of this equation. So we have the limit as delta x approaches 0 of delta y over delta x, which is equal to limit as delta x approaches 0 u delta v over delta x plus limit as delta x approaches 0 of v delta u over delta x plus limit as delta x approaches 0 delta u delta v over delta x. Now we can simplify this to be written as u limit delta x approaches 0 delta v over delta x plus v limit as delta x approaches 0 of delta u over delta x plus delta u limit as delta x approaches 0 delta v over delta x. Now we know that from our first principle differentiation that this limit of a function can be written as dy over dx. So that means our limit, our left hand side becomes dy over dx, and then our right hand side becomes this u dv over dx plus, now this is v, limit of this becomes dv over dx plus delta u dv over dx But we know that as delta x approaches 0, that delta u approaches 0 as well, and then delta v approaches 0. So this becomes 0. So this can be written as u dv over dx plus v du, this is u, sorry, du over dx plus 0 multiplied by dv over dx. So our dy over dx therefore becomes u dv over dx plus v du over dx. So this is our formula for product rule. Now let's go ahead to solve some examples. I'll solve 1 or 2 examples to illustrate this point or to demonstrate how this formula works. So let's say we have a function y equal to 3 plus 2x multiplied by 1 minus x. So this is our u from our function that we used in getting our product rule differentiation formula. This is our u, this is our u, and then this is our v. So this becomes our dy over dx from our formula, product rule formula, becomes u dv over dx plus v du over dx. So this is u and then this is v. So u is this 3 plus 2x, and then du over dx becomes 2, and then our v is 1 minus x. Therefore our dv over dx becomes minus 1. So therefore dy over dx becomes u, which is 3 plus 2x multiplied by dv over dx, which is minus 1, plus our v, 1 minus x multiplied by du over dx, which is 2. So if we open this bracket further, we have minus 3 minus 2x, and then this becomes plus 2 minus x. So we can simplify this further. Minus 3 plus 2 becomes minus 1, and then minus 2x minus x becomes minus 3x. So therefore our dy over dx becomes minus, if we factorize, take out the minus sign, we have that our dy over dx becomes 1 plus 3x. So this is our answer.